Yeah. Good evening, everyone. All good? और कौन सी क्लास चल रहा है आपके इसमें? ठीक. एनवायरमेंट एनवायरमेंट स्टार्ट हुआ है? Most probably. So last class we discussed regarding jet streams and air masses. So jet streams and air masses, very important concept. So jet streams, we discussed what are jet streams, characteristics of jet streams, mechanism of origin of jet streams, types of jet streams and significance of jet streams. Across the world, the different types of jet streams, their role in the climatic changes, weather pattern which happens across the world. Okay, so हमने discuss किया था इसके बारे में. So that includes modification in the local weather conditions, causing cyclonic, anticyclonic circulations. Okay, so and causing heat waves, cold waves, heat domes. How weakening of jet stream significantly impact the local weather conditions. Jet streams also impact the rainfall. Indian monsoon gets impacted. Western disturbance is also caused. There's a role of jet streams in temperate cyclone formation. Okay, so they are also used in navigation across the world. So the jet streams और क्या था? Air masses. Air masses, large cross section of air. We discussed what is air mass, what are the characteristics of air mass, and then types of air masses and significance of air masses. One of the most important significance of air mass is the formation of fronts. वो तो है desert formation, rainfall, okay, so वो सब तो है, but most important part of it is formation of fronts. Okay, so today we'll discuss regarding the formation of fronts, temperate cyclones as well as tropical cyclones. Any doubts from these two topics? It's all clear? So this was one of the PYQ from air masses. Okay, the same significance part which we discussed in the end. Okay, so it's about that. You need to briefly explain what are air masses, what do you mean, what are the characteristics of air masses, and their role in the local changes which happens across the world with example. Okay, so how it influences the climatic conditions across. Examples are very important here. Conclusion, you can talk about the changing nature of the air masses in the context of global warming. Okay, so and its significance. So next. Fronts and temperate cyclones. What are fronts? What is a front? So in general, what do you mean by front? Front का मतलब क्या है? Not सामने वाला front. That is one of the usage. Other than that, what do you mean by front? Have you heard of frontier region? Frontal zone? Borders, in the context of borders. So what is the difference between a border and a front? Why it was called as northwest frontier zone? Northeast frontier. What do you mean by front here? No, we don't find front everywhere. Front is a transition zone, whereas border is just a line. This is what is border. It is just a line. This is a zone. So, for example, India and Pakistan border at Rajasthan. Okay, so very clearly established border is there. It's a boundary line, a single line. From here, this side is India, that side is Pakistan. Fine. So, front example is Tibet. Earlier, it was considered as a front between India and China. Okay, so until Tibet was annexed by China. Okay, so फिर अभी border बन गया. Got the difference? Okay, where there is a transition zone, where there is no very clearly cut line demarcation. That is what is called as front. A front is a region which acts as a transition between two different regions. This is completely one area, this is completely another area. In between, there is no clear-cut demarcated area. There is a transition. The transition zone is what is called as front. Okay? The northwestern part of South Asia, the present-day Afghanistan, okay, so northern Pakistan region was usually referred to as the northwest frontier between British India and Russia. Okay, so Russia's influence was there till Central Asia then, right? So between these two regions, this acted as a front. So which British hoped that it would stop the Russians towards India. That's why they were fighting continuously even though they were losing. Okay, so at least that area may not be under complete control, but India will be completely under their control. Northeast region was also earlier used to be considered as a transition zone, frontier region. So frontier region is any kind of transition zone between two different regions. That is what is called as front. So in climatology, front refers to transition zone between two different types of air masses. We've studied about air masses. Air mass is a large area of atmosphere, okay, cross section of atmosphere with distinctive characteristic. It has its own characteristic, which you can very clearly identify. Okay, this is, let's say this is air mass. From the surrounding area, we can very clearly say, okay, this is what is air mass, इसके आगे air mass नहीं है. मतलब यहाँ पर पूरा यूनिफॉर्मिटी है. देयर इज कंप्लीट यूनिफॉर्मिटी है. इफ आई एम सेइंग दिस इज ए वार्म एयर मास, ये पूरा वार्म है. इसके बाहर वार्म नहीं है, यहाँ पर वार्म नहीं है, यहाँ पर नहीं है. और देयर इज नो यूनिफॉर्मिटी, देयर इज अ चेंज. सो दिस इज वन एयर मास. दिस इज अनदर एयर मास, कोल्ड एयर मास. Totally cold condition. When two different air masses are very far away from each other, there is no front. जब दूर दूर है तब तो फ्रंट नहीं है. Okay, so let's say this is a cold air mass. This is a warm air mass. ठीक है. In between there is no continuous zone. There's a very large area. We don't call this as front. When both of them come closer towards each other, जब दोनों पास में आएंगे तब आपको मिलेगा front. When both of them are closer towards each other, in between you will find a transition zone. So this transition zone is what is called as front. Transition zone for what? Transition zone between the warm and cold air mass. Two different types of air mass. Here it is completely warm, here it is completely cold. In between, the characteristics of warm is ending, cold is beginning. From that side, cold is ending, warm is beginning. It's almost a mix of both. However, along the fronts between the two different air masses, you will not see mixing of air. Okay, so we assume the air should mix. Okay, so this is also air, that is also air, दोनों gaseous particles हैं. When both of them are brought together, why don't they mix? That is the nature of air mass. Air masses don't mix up very easily, particularly opposite nature of air mass. Okay, जब दोनों अलग अलग टाइप का होता है, this is a cold air mass, this is a warm air mass, that is a cold air mass. Warm air mass will not mix up with the cold air mass will not mix up with the warm air. So what happens along the front? Along the front, an air mass tend to push each other. A warm air mass will try to push the cold air mass will try to push the warm air mass backwards. Fine? They don't mix up. That is what is happening in the front. Front is a zone where there is a transition. If you are standing in the front, on this side towards this side, there is a warm air mass, another side there is a cold air mass. Very clearly, stark nature you can observe. That is the region of front. Transition zone. Okay, write the definition. A narrow zone of transition separating two air masses of differing temperature and humidity. Separating two different air masses of differing temperature and humidity conditions. Humidity conditions. Full stop. They're usually found in mid latitude or temperate region. So what happens when two different air masses come closer towards each other? This is the top view. Okay, हम ऊपर से देख रहे हैं. This is the region of front. Okay, let's see a side view. Okay, this is surface. Imagine this is a cold air mass moving in this direction. We're taking the side view. Okay. This is a warm air mass. This is moving in this direction. Is there a front now? No. This is a little bit far away. When two different air masses come closer towards each other, then there is a front. So where is the front? Front is here, like this, from the side view. Okay. So there is a warm air mass, there is a cold air mass. Warm air mass is trying to push the cold air mass backwards. Cold air mass is trying to push the warm air mass backwards. During this, the cold air mass is denser in nature. Cold air mass is denser in nature. The warm air mass is lighter in nature. As they try to push each other, warm air mass being lighter in density gets uplifted by the movement of cold air mass. ठीक है? अब यहाँ तक ही बनाओ, आगे मत बनाओ, थोड़ा सा डिटेल में बताऊंगा. ठीक है? So don't draw this. This is fine. This is fine. यहाँ तक करो. This is how cold air mass moves. This is how warm air mass moves. Okay. So what happens when the warm air mass gets uplifted? The warm air mass being warm, there is also water vapor in it. Okay, wherever there is a warm air, so there is a tendency of evaporation, there is a good amount of water vapor. So when the warm air gets uplifted, the warm air cools down, water vapor cools down, and it condenses. Okay, where there is condensation, there is cloud formation, there is precipitation. Okay? All of these are happening. Initially, when I showed that warm air mass little bit away, there was no front. Two different air masses came closer towards each other, there is a formation of front. It's called as frontogenesis. Genesis is origin. Frontogenesis is the formation of front, which is due to the convergence of two different air masses. As they come closer towards each other, the air masses tends to push each other. Okay, so, and in this process, it results in the formation of front. As the fronts are formed, there is a change in the surrounding weather conditions. Okay, so it may involve the rise in temperature or fall in temperature. दोनों हो सकता है. If the cold air mass is coming in this direction, the temperature drops. Warm air mass is coming in this direction, temperature rises. There is a change in the temperature, change in the pressure condition. If temperature changes, pressure also changes. Change in the temperature, change in the pressure, changes in the wind speed, condensation, cloud formation, rainfall, all these changes are happening. This is what happens during frontogenesis. Okay? All of these are happening. Imagine after some time, the difference in pressure in a different direction causes one of the air mass to move totally in a different direction. Earlier the pressure difference was towards each other. Now the pressure difference caused this air mass to move in this direction, this air mass to move in another direction. It totally caused them to move in a different direction, and after some time, if you see, there is no front only. The front has come to an end. It's called as frontolysis. Frontogenesis. Decay of front is frontolysis. Frontolysis is the process of decay. Frontolysis can also happen whenever the contrasting nature of the air masses comes to an end. The warm air mass is no more warm, it has cooled down completely. Or cold air mass is also a little bit heated up. There is not much of contrast. The front exists as long as there is a contrasting nature. In that case also, let's say air mass पूरा ऐसे खत्म होने का stage में है, they are undergoing dissipation, and during that they are merging. Gradually they become weaker and dissipates and then disintegrates. In that case also front will come to an end. That is called as frontolysis. Frontogenesis, frontolysis. With frontolysis, temperature, weather, all of this start to become normal. There is not much of disturbance. Okay? So write about this. Next, frontogenesis. It is the process of formation or intensification of a front due to the convergence of two air masses with differing characteristics convergence of two air masses with differing characteristics. Next point. Frontogenesis result in changes in temperature, pressure, wind speed, cloud formation, rainfall, etc. Next, frontolysis. Frontolysis is the process of weakening or dissipation of a front weakening or dissipation of a front due to divergence of air masses or mixing of their characteristics mixing of their characteristics. Next point. Frontolysis results in Reduction of temperature and pressure contrast. Reduction of temperature and pressure contrast. Come on. Uniform winds. Come on. Disappearance of clouds and rainfall with clear sky. Disappearance of clouds and rainfall with clear sky. Types of fronts. See, front is a transition zone between two different types of air masses. Why did I tell you that it happens only in the temperate regions? Why not tropical region? Why not polar regions? Why only temperate regions? So it is the region where there is two contrasting air masses usually meet. Okay, so here there is both cold and cold. Here there is both warm and warm. Two contrasting air masses meet here. Usually the polar and tropical air masses. Okay? It is usually the polar and tropical air masses meet here as well as here. Therefore, it is always the temperate regions where there is front formation. That is one of the reasons why there is no temperate air mass. For air mass formation, you need stable, uniform condition. The formation of front never lets the conditions to be stable and uniform here. Okay, so यहाँ से जो आता है, यहाँ से जो आता है, यहाँ पर मिलके हमेशा वो disturbance create करता रहता है throughout the year. So therefore, this is not a very stable area. ठीक है? Now, the types of fronts. It all depends upon the stage of front formation. It begins with stationary front. What is a stationary front? Stationary front is where two different air masses have come closer towards each other. This is a cold air mass. This is a warm air mass. Both are trying to push each other, or both are completely stationary. Okay, they are just closer to each other without much movement. This is a warm air mass. This is a cold air mass. This is a front, and this type of front is called as stationary front. So here there is just front, there is not much of movement. A front which is not at all moving, stationary front. Because either both the air masses are moving at the same speed, or they are not at all moving, or they are moving parallel to each other. Okay, so near to the fronts, none of the air mass is pushing the other one strongly. Okay? Or they are not all pushing. They are not moving at all. Okay, so imagine दो कबड्डी टीम है, ठीक है, तो इस साइड में आ रहे कोल्ड कबड्डी टीम, वहां से आ रहे वार्म. Okay, so both the teams, they are just standing next to each other, near to that front zone. They are trying to see and assess each other's strength. Okay, so देखते हैं पहले, ठीक है, कौन किसका स्ट्रेंथ ज्यादा है किसका कम है, पहले असेस करना है. और दे आर लाइक ट्राइंग टू पुश ईच अदर एट द सेम स्पीड. ठीक है, that is what is called a stationary front. Stationary front, there is not much of cloud formation, not much of weather changes. There is just a sudden change in the temperature can be visible. If you are standing in a stationary front, on this side there is a cold, on that side there is a warm air. But there is not too much of wind shift, pressure changes, temperature changes being observed. In terms of disturbance in the atmosphere, cloud formation, precipitation is not happening. And how long can you see each other like this? धक्का मुक्की तो होगा थोड़ा बहुत. With the disturbance of a stationary front, it results in either cold front or warm front. ठीक है? Whenever a stationary front is disturbed, it causes cold front or warm front. In both the cases, it is always the warm air which gets uplifted, cold air undercuts. Okay, so let's use two terms here. Okay, so these are specific terms, you have to use it as it is. So whenever there is two different air masses coming closer to each other, the movement of cold air mass is always below. Is that right? The warm air mass is always above. Is that right? This is how every air mass interaction happens. When both of them are moving towards each other, the warm air mass gets uplifted, cold air mass undercuts. The terms are, the moving of warm air above the cold air is what is called as overriding. The warm air mass is overriding the cold air. The cold air is undercutting the warm air. This is undercutting, this is overriding. Okay, along the front, this is what happens. On one side, the warm air mass is overriding, cold air mass is undercutting. So then how do we differentiate a warm front from cold front? In both the cases, there is warm air on one side, cold air on another side. It all depends upon who is moving faster. If a cold air is moving faster, it is called as cold front. If a warm air is moving faster, it is called as warm front. Whether the cold air is moving faster or warm air is moving faster, in both the cases, it is always the warm air which gets uplifted and cold air undercuts. Warm air overrides, cold air undercuts. Okay, so whether cold air is trying to push the warm air backwards or warm air is trying to push the cold air backwards, in both the cases, the warm air gets overridden. Okay, so warm air overrides, cold air undercuts. But the nature of overriding and undercutting is different. That makes the difference of cold front and warm front. Okay, first let's see warm front. So what is a warm front? Warm front is a frontal zone where the warm air mass is moving faster than the cold air mass. Imagine the cold air mass to be totally stationary. This is cold air mass, this is not moving. It is the warm air mass which is moving faster and it overrides the cold air mass by itself. Okay, तो ये कुछ नहीं कर रहा, cold air mass तो बस ऐसा ही खड़ा है. And the movement of warm air mass causes it to override above the cold air mass. This type of front is called as warm front. This is what is warm front. And as the warm air mass rises above the cold air mass, it creates a frontal zone like this. This is what is front. Along the warm front, the cold air mass is overriding the, warm air mass is overriding the cold air mass. It causes the warm air mass to rise above the cold air mass by itself. वो खुद ऊपर जा रहा है. It is going by itself. Nobody is forcing him to go. Cold air mass is just standing over there. Okay, our cold competitive team is just standing. It is the warm competitive team who is jumping on them. In that case, the cold front is it is where our cold competitive team is moving forward. The other team is they were just standing. But what happens if this cold air mass moves forward? Then also it is the warm air mass which gets uplifted. Can you see the nature of upliftment? When the warm air mass rises by itself, it rises gradually above the cold air mass because cold air mass is not moving or not much movement is there at all. Whenever the cold air mass undercuts the warm air mass rises rapidly. Okay? It gets rapidly uplifted. Okay, so imagine the warm air mass. Okay, so the warm kabaddi team is just standing. Suddenly नीचे से आके ऐसे धक्का दे दिया. I guess जहां पर खड़े थे पूरा ऐसे suddenly उड़ गया. Suddenly gets uplifted. Here the front is little bit steeper. Can you see? Here the front has a gradual slope, here the front has a steeper slope. This is the basic difference between warm front and cold front. Okay, so let's differentiate. A warm front is the one where warm air mass is advancing faster and overriding above the cold air. A cold front is the one where the cold air is advancing and undercutting the warm air. ठीक है? Along the warm front, the warm air rises gradually above the cold air. Along the cold front, the warm air rises abruptly above the cold air. Right? Along the warm front, the gradient of the front, that is slope of the front, is gradual. Along the cold front, the gradient of the slope, the gradient of the front, that is slope of the front, is steeper. Now comes the major difference. Whenever the warm air mass is rising upwards, it undergoes cooling and condensation. There is a cloud formation. In both the cases, you can already see that there is a inversion zone. दोनों में inversion zone बनी है. यहाँ पर भी temperature inversion है. Frontal inversion, here also frontal inversion. Both are inversion. The cold air condenses and results in the formation of fog near to the ground. There is a fog formation. The upliftment of warm air causes it to undergo condensation. As the moisture condenses, there is a cloud formation and precipitation. What do we call this precipitation as? Frontal rainfall. In both the cases, there is a frontal rainfall, but the nature of rainfall is different. Here, the warm air rises gradually above the cold air. Whenever the air rises gradually, it cools down gradually. When it cools down gradually, it results in the formation of clouds which are not very dense. It causes the formation of layered clouds which are filled with moisture. What do we call them as? Layer filled with moisture. Layer rain bearing. Nimbostratus clouds. nimbostratus clouds. They get dispersed over large area. Whenever the air rises rapidly, it undergoes rapid upliftment. It results in the formation of cumulonimbus clouds. The rapid upliftment causes cumulonimbus clouds. With this occupying a smaller area. And nimbostratus clouds causes rainfall over large area. देखो यहाँ से यहाँ तक. Cumulonimbus clouds causes rainfall over small area. Nimbostratus clouds causes moderate rainfall. Cumulonimbus clouds causes heavy rainfall. ठीक है? So along the warm front, you observe a moderate rainfall formation of nimbostratus clouds. Along the cold front, you see the formation of cumulonimbus clouds and heavy rainfall. I told you very clearly, you cannot use your own terms. You have to use the same word which I have given. Rising warm air is called as overriding. Okay, so the cold air moving below the warm air is called as undercutting. Okay, so undercutting, overriding. It's not different. It's not same from the convection, subsidence. वो सब अलग है. Okay, don't use those terms here. So this is cold front, this is warm front. Okay, so see the warm front first. Here the air movement is opposite. This is warm air, this is cold air. The warm air is moving, it is overriding the cold air. The gradual upliftment, the slope is gradual. It causes nimbostratus clouds. Moderate rainfall over larger area. Here the warm air mass is undergoing rapid upliftment. The cold air mass is undercutting. The rapid upliftment causes cumulonimbus clouds. Over smaller area, heavy rainfall. Okay, so the gradient of the slope is steeper, occupying only smaller area. This is a cold front, this is a warm front. कितने types का हो गया fronts? Stationary front, warm front, cold front. There is a fourth type. I'll tell you about that. First write this. Stationary front. When the surface position of a front is not changing, when the surface position of a front is not changing, when the two air masses are unable to push each other, it's called as stationary front. Next point, when this front is disturbed, it results in the formation of warm front or cold front. It results in the formation of warm front or cold front. So Why is it that stationary front is not changing? Because in case of warm front or cold front, the position of the front is never fixed. Okay, there is always the movement of the front. Front position is here. Okay, so we see the position of the front on the ground. Where is the position of the front? Here. From here it is tilted. That is a different thing. But the position of the front is here. Okay, so in this case it is here. If the cold air mass is continuously moving, the front itself is continuously changing like this. It changes in this direction. Right? The position of the front is always changing. Here, it again depends upon the movement of cold air only. Warm air cannot change the position of the front. Because what happens when the warm air moves? It overrides. Is it right? Warm air यहाँ से ऊपर जाएगा. ये जो पोजीशन है उसको पीछे होगा या नहीं होगा वो डिपेंड करता है कोल्ड एयर के ऊपर. But usually it keeps changing only. Cold air is not never stationary. Cold air also keeps moving either on this side or on this side. In any direction, the front keeps changing. So that is why it is a warm front and cold front which continuously keeps moving. The front itself keeps moving. Stationary front remains stationary. There is no movement along the stationary front. The front itself is not moving. So next, warm front. It is the front between warm and cold air mass where warm air mass is advancing and overriding over cold air mass. Next point. The gradient of the front is gradual. The gradient of the front is gradual. Leading to slow ascent of warm air. Ascent is rising and a slow rising of warm air. Next point. It results in the formation of nimbostratus clouds. Next point. It causes moderate rainfall over larger area. Moderate rainfall over larger area. Next, cold front. It is the front between warm and cold air mass. Where cold air mass is advancing and undercutting. Cold air mass is advancing and undercutting the warm air mass. Undercutting the warm air mass. Next point. It results in steeper gradient. It results in steeper gradient. Gradient is slope. Steeper gradient along the front. Next. It causes rapid upliftment of warm air. Next point. Results in the formation of cumulonimbus clouds. Next point. It causes very heavy rainfall. But over a smaller region. So this is how air masses would interact with each other. Okay, just a small experiment to show their interaction. Here air masses are represented by water, because you know even air masses would behave like water, or water would behave like air mass. Okay, so they have taken two different temperatures, the water with two different temperature, one warm, another cold. Okay, this is warmer, that is colder. You can see both are separated by some divider. Now they just remove the divider. You can see whether they mix up or how exactly it happens. Can you see? The cold air mass always undercuts. Warm air mass overrides. And the undercutting causes the position of the front to continuously shift. So when the entire cold air mass completely shifts, the entire warm air gets completely uplifted.
Air masses are gigantic atmospheric volumes with very specific temperature and humidity characteristics. When two different air masses come into contact, they don't mix. They push against each other along a line called a front. When a warm air mass meets a cold air mass, the warm air rises since it is lighter. At high altitude, it cools, and the water vapor it contains condenses. This type of front is called a warm front. It generates nimbostratus clouds, which can result in moderate rain. On the other hand, when a cold air mass catches up with a warm air mass, The cold air slides under the warm air and pushes it upward. As it rises, the warm air cools rapidly. This configuration, called a cold front, gives rise to cumulonimbus clouds, often associated with heavy precipitation and storms. As air masses move, pushed by winds, they directly influence the weather in the regions over which they pass. In this way, they help to circulate heat and humidity in the atmosphere.
ठीक है? That is stationary, warm and cold air. Sorry, stationary, warm and cold fronts. The fourth type of front is occluded front. Okay, so write this. Fourth one, occluded front. OCCLUDED, occluded. What is a occluded front? A warm front or cold front is when a warm and cold air mass meet. Wherever there is a meeting of warm air mass and cold air mass, it results in the formation of warm front or cold front. When a warm front meets the cold front, that results in occluded front. Occluded front is basically merger of two different fronts. वो कैसे होगा वो मैं समझाऊंगा, वो मेरा जिम्मेदारी है, चिंता मत करो. ठीक है? So what is a occluded front? When two different fronts will merge together. ठीक है? That is through the formation of these fronts and temperate cyclones. That is how it happens. Okay, we'll see that. Just imagine it is happening. Imagine from one side there is a front moving. I told you fronts are not fixed. The fronts keep moving. Warm front also shifts. Cold front also shifts. Now two different fronts will merge together. That merged front is called as occluded front. Okay, so here is an example. This is a cold front. How are we saying that this is a cold front? You can see that cold air mass is advancing faster. The warm air mass undergoes rapid upliftment. There is a cumulonimbus cloud. This is cold front. As the cold air mass is moving in this direction, cold fronts keep shifting like this. This is a warm front. There is a warm air here. Air mass is a very big area, okay? Air mass is not some small air parcel, right? It's a very big area. There is a great chance that on one side there is a cold front, another side there is a warm front, possible hai? So here the front is continuously advancing and pushing the air mass upwards. Usko upar utha ke jayega. What happens to this rising air? It becomes clouds and it cools down, and as it cools down, it loses the character of air mass itself. It is gradually getting mixed with the surrounding atmosphere. So what is happening to the warm air mass? Warm air mass is gradually getting dissipated. वो खत्म होते जा रहा है. जितना फ्रंट वो मूवमेंट आएगा तो ये एक साइड से वार्म एयर को खाते आ रहा है. Like it is finishing of warm air. On the other hand, here the warm air mass is rising. Imagine the cold air is moving in this direction, or it is totally stationary. That is what is warm front. Warm front is decided based on the movement of warm air. Will this front move in this direction or this direction? If the cold air is stationary, what happens to the warm front? Warm front will not move much. Very rare case that the cold air remains stationary. I am telling you, imagine if the cold air is stationary, will the warm front move? No. The movement of warm front is always decided by the movement of cold air. If the cold air moves in this direction, the warm front also moves in this direction only. If the cold air moves in this direction, warm front also moves in this direction, even though the warm air is rising in this direction. It doesn't matter in which direction the warm air is moving. It's always the cold air which will decide the direction of movement of front. ठीक है? The cold air is not moving faster in this direction. अगर ये faster movement है तो ये cold front बन जाएगा. इस ज़्यादा movement में नहीं. Either it is moving slowly or it is moving in this direction. जो भी हो रहा है. It is happening in such a way that the cold front which is coming in this direction gradually catches up with the warm front. After some time, if you see, the cold front has got mixed with the warm front. ये fast आ रहा है ना, because it depends upon the movement of cold air. Cold air is advancing and undercutting at a faster rate. So the cold front shifts faster, and as it shifts faster at one point of time, it will meet the warm front. That causes the merger of both cold front and warm front. What happens? The entire warm air which is present in between will get completely uplifted. क्योंकि इस साइड से भी कोल्ड एयर आ गया, उस साइड से भी वैसे ही कोल्ड एयर है. कोल्ड एयर आके कोल्ड एयर को मीट कर लेगा, दोनों मिक्सअप हो जाएगा, दोनों भाई भाई. कोल्ड एयर एंड कोल्ड एयर विल मीट अप. कोल्ड एयर एंड वार्म एयर विल नॉट मिक्स अप. What happens to the warm air which is there in between? Completely gets uplifted. And it also cools down. Because once the warm air gets uplifted, it will completely cool down in the upper atmosphere, right? The warm air will gradually lose its characteristic. So then who won? Which kabaddi team? Because the nature of the warm air is like that. Warm air always undergoes upliftment. As the warm air undergoes upliftment, it will become cold. जीतेगा तो cold air. But the merger of both the types of fronts causes very heavy rainfall. Occluded front causes very heavy rainfall, thunderstorm, lightning, because all the system is merged together. The clouds from the warm front is also mixed. The clouds from the cold front is also mixed. Okay, heavy rainfall happens because all the warm air is getting uplifted here. But after some time, there is no more warm air left to get uplifted. So cloud formation stops. Rainfall also stops. The clouds will become thinner and get dispersed. If you see from the lower level, it's all cold air. Warm air, after rising, it will also gradually become cold. Then everything gets mixed up. This is what is occluded front. Occlusion is the process of formation of occluded front. Occlusion. With the occlusion, the fronts will come to an end. We call it as frontolysis. Frontolysis ऐसे होता है. Frontolysis is there where there is no front existing. Front तो पूरा खत्म हो गया ना, पूरा नीचे से आके warm air, cold air occupy कर लिया. There is no more front left. Everywhere it is cold air only. This is called as occluded front. So write about this. First point. It is the later stage of front formation. Where the air in warm sector is no longer at the ground surface. No longer at the ground surface due to the meeting of cold front and warm front. Next point. It is a complex zone with both cold and warm front characteristics. Complex zone with both cold and warm front characteristics. Next point. The process of formation of occluded front. Is called as occlusion. Next point. With occlusion, and complete upliftment of warm air, with occlusion and complete upliftment of warm air, it results in frontolysis. So next subheading, temperate cyclones. What is a cyclone? We have already studied what is cyclone. कहाँ पर याद है? Pressure belts. Good. What is a cyclone? That is wind. Don't use the word belt. Belt refers to the zone. Their nature is geostrophic sometimes. Not necessarily it has to be geostrophic. It usually is geostrophic. But what is a cyclone? Circulation of air around the low pressure air. A cyclone refers to a region of low pressure where the surrounding air is trying to move towards the center, and during that process it gets deflected and starts to circulate around the low pressure. This is what is isobar. Red line is isobar, the blue line is how the winds are moving. Okay, there is a low pressure at the center, and around that the winds are trying to circulate. Winds are circulating. Because of the low pressure, the winds are drawn towards the center. Low pressure attracts the winds from the surrounding area. They are drawn towards the center. As the winds move towards the center, they get deflected towards the right side. Okay, they tend to become geostrophic if the Coriolis force is strong enough. Otherwise, they converge and circulate and rise. Such kind of system is what is called as a cyclone. Anticyclone is opposite, where there is high pressure at the center and the winds are moving away from the center and counterclockwise. Okay? So this is what is called as a cyclone. A cyclonic system can be developed anywhere across the earth. Low pressure can be developed anywhere across the earth. Those cyclonic systems which are developed near to the tropical regions, they are called as tropical cyclones. Those which are developed near to temperate regions, they are called as temperate cyclones. Temperate cyclones, they are also called as extratropical cyclones beyond the tropics. Temperate cyclones, they are also called as mid-latitude cyclone, referring to temperate zones. Or they are also called as wave cyclone. Why? I'll tell you. Whenever there is a low pressure region around the temperate regions, जहाँ पर temperate regions है ना, temperate latitudes, if at all there is a development of low pressure, it is in the same region there is also front formation happening. Okay, fronts are happening, there is a warm front, low, cold front, all of these are happening. This gets intensified with the help of these fronts. Okay, they get intensified with the help of these fronts, and they use the system of fronts to get intensified and become a huge cyclonic system, which is causing very heavy rainfall, Okay, heavy clouds, all of this. They make use of this surrounding fronts to their advantage and grows on to become huge cyclonic systems. They are called as temperate cyclones. In tropical regions, there are no fronts. Fronts are not formed in tropical regions. Still, they form a cyclone over there. Cyclone के लिए you don't need fronts always. साइक्लोन के लिए चाहिए लो प्रेशर. लो प्रेशर को मेंटेन करने का कुछ मैकेनिज्म चाहिए. यहां पर फ्रंट्स के वजह से वो मेंटेन होता है, वहां पर हाई टेम्परेचर की वजह से मेंटेन होगा. ठीक है, वो अलग सिस्टम है. विल सी दैट. सो व्हाट हैपेंस हियर? इट ऑल स्टार्ट्स विथ स्टेशनरी फ्रंट. Okay, stationary front begins with the two different air masses coming closer towards each other. This is all top view. ऊपर से देख रहे हैं हम. This is a warm air mass moving in this direction, cold air mass coming in this direction. As they come closer to each other, first there is a formation of front. What kind of front? Stationary front. Stationary front is not moving, it is totally stationary. Okay, there is no cloud formation, there is no rainfall at all. The disturbance of stationary front results in the formation of wave front. अभी wave front क्या है? Wave front तो सेम ही है warm front, cold front का ही. नेचर को हम wave front बोलते हैं. Usually the front gets disturbed with the formation of low pressure somewhere. Along the entire region there is some low pressure gets developed. जहां पर low pressure है, depression है. Imagine there is a low pressure here. If the low pressure is developed here, what happens to the air movement? The air which is present here tends to converge in this manner. The air which is present here tends to converge in this manner. Okay, counterclockwise movement. That will push the cold air from this side and warm air from this side. Okay, cold air gets pushed from this side. Warm air gets pushed from this side. The movement of cold air in this direction results in the formation of cold front. The movement of warm air in this direction results in the formation of warm front. So on one side there is a cold front, another side there is a warm front, in between there is a low pressure. It takes the shape of a wave. Therefore this is called as wave front. It is associated with the wave front, therefore it is also called as wave cyclone. Okay, simple. But this will not stop here. I told you these fronts will not remain fixed. The position of these fronts continuously keep changing. Why? The cold front is continuously moving. This is moving faster. Because as the cold air gets pushed in this direction, the position of the front continuously shifts like this. Because the cold air is undercutting. As the warm air is moving in this direction, the position of the warm air may not change. Because the warm air is overriding. Okay, so in this case, the warm front may shift slowly, depending upon the movement of the cold air if it is moving in this direction. But however, the cold front is shifting faster. Gradually what happens? The gap between the cold front and warm front is narrowing like this. Gradually from a wave front, it becomes a V-shaped front. The gap between the cold front and warm front is narrowing down. The third stage, from wave, it will turn into V-shaped. In the fourth stage, it has come very closer, just before merging. That is fourth stage. The fifth stage is where both the fronts will merge together. That is what we call it as occlusion. The occlusion happens with the merging of warm front with the cold front. Okay, that is what is occlusion. And it starts from this point. जहां से ये diverge हुआ था ना, वहां से शुरू होगा. From this point where both the fronts are forming. From here the occlusion starts. Okay, so gradually the fronts will start to merge. It's like, okay, so इसको कैसे? जैकेट का ऐसे हम zip लगा देना ऐसे, नीचे से ऊपर. Okay, so from here you're closing it. Okay, from here the occlusion is happening. With occlusion, what happens? A huge amount of warm air gets uplifted. When huge amount of warm air gets uplifted, condensation happens. The air cools down. What happens during condensation? Before precipitation? Before cloud formation? Yes, the release of latent heat. Latent heat is released in huge quantity. With the release of heat, pressure drops further. The low pressure further causes the movement of more air mass towards it. More convergence happens. This system continues. Okay, this entire part is not fixed in one position. It continuously is changing. With the release of more latent heat, with the release of more energy, temperature further increases, pressure drops, more disturbance is created, and the fronts are continuously maintained. As long as there is warm air left here. Okay, so once the entire warm sector is completely uplifted, once the entire warm sector undergoes occlusion, now there is no more warm sector left, then the frontolysis. Okay, so with the occlusion happening, this entire warm sector is completely getting uplifted. There is heavy rainfall, thunderstorm, lightning, sab kuch ho raha hai, everything is happening. The occluded front. But once the entire warm sector is uplifted, here everywhere there is cold air. Okay, there is no more warm air left. All the warm air which is here has gone below. ये थोड़ा सा नीचे आ गया. फिर यहाँ से warm air है, यहाँ पर cold air है. If they are still different from each other, if there is enough difference between the warm air and cold air, there is another front developed here. Again, it comes back to the first stage. Okay, so from the occlusion, frontolysis happens. With frontolysis, frontogenesis would begin. Okay, in another place, not in the same place. Because air mass is a very, very big size, okay, covering a large area of few hundreds of kilometers. The front would also extend like that. It covers few thousand kilometers. This is what is called as temperate cyclone. Temperate cyclones are low pressure system which are getting intensified with the help of formation of fronts. As the fronts develop, cloud formation happens, rainfall happens, latent heat gets released, and the weather continuously changes. As long as there is a difference of warm air mass and cold air mass, the system continues to grow. And once the difference is not much, the cold air mass has become little bit warm air mass has become little bit cold, both of them get mixed together, and there is total khatam. And again you have to wait for the next air mass to form over there, here, and again move towards each other. It's a continuous process which happens throughout the year. It impacts this entire surrounding region around mid latitudes. Mid latitudes के पूरा surrounding region को impact करता है. यहाँ से continuously warm air mass बनेगा, यहाँ पर move होगा, cold air mass बनेगा, यहाँ पर move होगा, यहाँ पर ये interact होके fronts बनते जाएगा. Temperate cyclone को कैसे depict करेंगे हम? यहाँ पर जब meet होगा ना तो ऐसे बनता है. This is how the temperate cyclones are formed. With the position continuously shifting, fronts continuously shifting. Okay, so you will have to draw this figure. 6th stage. Just quickly repeat this. First stage is stationary front. Okay, where two different air masses have come closer towards each other, there is a formation of stationary front. Second stage is wave front, because with the development of low pressure somewhere, cold air mass gets pushed on one side, warm air mass gets pushed on another side. There is a cold front, warm front. Okay, so as the cold front advances towards the warm front, the gap between the cold and warm front starts to become narrow. Okay, at one point of time, this is the closest, and after that, occlusion starts. With occlusion, heavy rainfall, thunderstorm, lightning, all of this will happen. Okay, the warm air completely gets uplifted. Okay, so when the warm air is completely uplifted, the entire front merges, and then there is a frontolysis. Whatever the leftover warm air is pushed downwards. If there is enough contrast, again a new front is formed from here. Okay, now you understood how these two will meet. Okay, let me show. This is side view, this is top view. Okay, this one is here, this is here, this is here. Okay, can you see, if you see from the side, this is the cold front, this is the warm front, in between there is a warm air. This is the cold front, this is the warm front, this is the warm air. As both of them come closer towards each other, here there is occlusion. This part is represented here. The cold front merging with the warm front, cold front merging with the warm front. Once the occlusion happens, the entire warm sector is uplifted. Here also cold air, here also cold air. Both of them merge together. Warm air after uplifting, it dissipates. There is no more left. Okay.
When two different air
The
masses
same
come into
repeated part,
contact, they
it
don't
will continue.
mix. They push against each other along a line called a front. When a warm air mass meets a cold air mass, the warm air rises since it is lighter. At high altitude, it cools, and the water vapor it contains condenses. This type of front is called a warm front.
This is how the nimbostratus clouds are formed, warm front.
On the other hand, when a cold air mass catches up with a warm air mass, the cold air slides under the warm air and pushes it upward. As it rises, the warm air cools rapidly. This configuration, called a cold front, gives rise to cumulonimbus clouds.
These thick clouds, cumulonimbus clouds. This is how the occlusion is going to happen. Okay, this is a cold air, that is a cold air. From here it is merging, here is the lowest pressure. Okay, the warm air is getting pushed like that. This is how the warm air is. Can you see? This is North America, Pacific Ocean. The cold air is coming here. Okay, let me draw this. This is cold front. Can you see thick clouds? Cumulonimbus clouds. Okay, so this is all cold air. This is all cold air. Cold air is getting pushed like this. Okay, where is the warm air? This is all warm air. It is moving like this. As the warm air gets moved here, can you see dispersed clouds? Okay, this is all nimbostratus clouds, dispersed clouds. Here the convergence is happening. You can very clearly see the converging air. This is the low pressure. Okay, where the air is converging like this. And there occlusion is also happening. Okay, this is how it keeps shifting. This is a time lapse video. It will not shoot so fast. Time lapse video. Okay, satellite imagery. It was a very, very large area. This is how the cold air is moving. You can see the movement of cold air like this. These systems are they're continuously shifting, right? The cold front shifts continuously, warm front also shifts, even though they're not as fast as the cold front. The weather rapidly changes in this region. Wherever all these fronts are formed, cyclones are formed, the weather rapidly changes. Suddenly it changes. Okay, so you will see temperature dropping suddenly. You are in cold air mass. Suddenly temperature rises, you are in warm air mass. Okay, they're totally dry condition. Suddenly the moisture increases, you are in warm air mass. Okay, so there is totally sunny conditions. Suddenly heavy rainfall starts. Again it disappears because these positions continuously shift, right? That is what is the weather of UK. Continuously changing weather. There is no climate over there. That is what we said. UK has no climate. Continuously, these things happen throughout the year, right? Okay, so the changing nature of the weather. So if at all any of you have watched Wimbledon, okay, so do you guys watch Wimbledon? You will see this. So it's an open court, and in that they keep playing, and suddenly rainfall starts. They take rest. They know that the rain is going to stop anyway. Okay, so again it will start. That is what is temperate cyclones. Temperate cyclones are strongest during winter. Why? It is during the winter you find the maximum contrast between the air masses. Cold air mass is very, very cold. Warm air mass is comparatively warm because it comes from a tropical region. During the summers, cold air mass is not going to be very, very cold. It's because of that. What is the role of jet streams in temperate cyclones? So imagine this, remember this. As jet stream moves, in some places it causes divergence, in other places it causes convergence. And jet stream always moves between the two different air masses. That is where it is usually stronger. Here there is a warm air mass, another side there is a cold air mass. Both are there in their position. Jet stream starts to blow in between. The movement of jet stream causes surface cyclonic, anticyclonic circulations. Leo about the anticyclone, okay, see the cyclonic circulations. Wherever the air is converging within the jet stream, wherever the wind is diverging within the jet stream, there it causes convergence from the surface. Near to the surface, there is low pressure. Now this low pressure will cause the air mass to move towards that because low pressure will attract the air masses. And as the air masses come closer to each other, there is a formation of frontogenesis, frontolysis, it will start. Or if there is already a front, the formation of low pressure will intensify them, causes a stronger front formation, stronger movement of air masses. So it's always good. Having a jet stream above is good for these fronts to form very easily. ठीक है, ये लोग मतलब अपने आपस में तो चिल है, तो ये जेट स्ट्रीम आके दोनों के बीच में झगड़ा करवा रहे हैं. It is intensifying, it is causing the formation of fronts, right? That is the role of jet stream. तो कहानी तो इतना ही है, आपको थोड़ा सा मसाला ऐड करना पड़ेगा. You have to explain jet stream causes the upper divergence causes lower convergence and then brings the air masses together. So ये है temperate cyclones. ठीक है? So draw this figure. Continue after the break. Yeah. So please write temperate cyclones. Temperate cyclones are also called as mid-latitude cyclones or extratropical cyclones or wave cyclones. Wave cyclones. Next point. They are prominent between 35 to 65 degrees north and south. Prominent between 35 to 65 degrees north and south. Next. There are 6 stages in temperate cyclones. First one. Convergence of two air masses with differing characteristics. Convergence of two air masses with differing characteristics. Air masses result in the formation of stationary front. Result in the formation of stationary front. Second, the warm and cold air masses penetrate into territories of each other. Penetrate into territories of each other, forming a wave front. Forming a wave front. Third, with warm and cold fronts starting to move towards each other, warm and cold fronts starting to move towards each other, warm sector is wedged between cold sector. Warm sector is wedged, W-E-D-G-E-D, wedged between cold sectors. Next point. Warm sector is narrowed due to the advance of cold ones. Advance of cold ones. Next point. Occlusion starts with warm air rising completely over cold air. Warm air rising completely over cold air. And cold front completely overtaking warm front. Next point. Warm sector completely disappears. Occluded front is eliminated. And cyclone dies out. Cyclone dies out. ठीक है, 6 stages. Subheading: role of jet streams in temperate cyclones. Role of jet streams in temperate cyclones. Jet streams being quasi-horizontal in nature. First point. Jet streams being quasi-horizontal in nature. Result in upper divergence in some locations. Result in upper divergence in some locations, comma, which allows surface convergence. Which allows surface convergence. Next point. This helps in bringing together warm and cold air masses with subsequent intensification, with subsequent formation or intensification of fronts. अगर यही चीजें सदर्न हेमिस्फीयर में हुआ तो कैसे होगा? तो टेम्परेट साइक्लोन्स, नॉर्थर्न हेमिस्फीयर में ऐसे बनता है ना. व्हाट अबाउट सदर्न हेमिस्फीयर? Same thing, imagine. In southern hemisphere, this will be warm and this will be cold. This is more near to the equator. This is away from the equator. Okay, so and there is a low pressure here. Cold air gets pushed in this direction. Why? The movement around the low pressure is clockwise. Movement around the low pressure here is anti-clockwise. Movement around the low pressure here is clockwise. This is warm, this is cold. Cold air gets pushed here. Warm air gets pushed here. Here in this direction there is cold front. Here in this direction there is warm front. ठीक है, तो एक्चुअली उल्टा है. जब लो प्रेशर ऐसे बनेगा, ये ऐसे होगा. This is how the cold front will start to advance. वेव ही उल्टा बनता है. ठीक है, इतना सोचने का जरूरी नहीं है, कोई पूछ लिया इसलिए बता रहा हूँ. Okay, so as the cold air gets pushed here, फिर gradually ये ऐसे बनेगा, V front ऐसे बनेगा, फिर ऐसे बन जाएगा, फिर occlusion होगा. ठीक है, next tropical cyclones. Yes, yes. No, usually not. Because the movement of the front is always influenced by the cold air mass. It's the warm air which gets wedged between the cold air masses. Tropical cyclones. So how many of you are from coastal region? Eastern coast? Eastern coast. Somebody was there from Andhra Pradesh? Vijayawada. Bajwada. ठीक है. Anyone else? Guntur. Guntur Karam. No, Guntur is known for Mirchi. Anyone from Odisha? No? Kolkata? Where? Which place? Birbhum, okay. So in 1999, there was a very big cyclone which hit Odisha coast. It was such a big cyclone, it is called a super cyclone. Super cyclone is like Godfather. Dawn के लिए dawn. It caused such a huge devastation. The entire part of Odisha as well as northern Andhra Pradesh. Okay, so it was total devastation. Even some parts of Bengal also, West Bengal. For 2-3 months there was nothing. Like everywhere water submergence, bridges collapsed. Okay, so and flooded areas. There's no transportation. There's no electricity. Many people died in that. Okay, so one of the most disastrous event which India had witnessed in the recent times, 1999 super cyclone. I don't think any of you would remember that. Anyone who is not born by then? That's big. So I was back then in high school. So we did chanda collection. Okay, so because it was that scale, no, it's unimaginable scale. Everywhere people used to donate, not only money, even the material used. Okay, so that is the nature of tropical cyclone. It's called as tropical cyclone. So since the name is cyclone, here also it is associated with low pressure. There is also low pressure area. The center there is a low pressure, but here there is no formation of fronts. What keeps this system running? What causes the system to become so large and destructive? It is convection. There it is driven by the fronts. Here it is driven by convection. Convection is basically the rising air. Convection can happen at high temperature. It is driven by high temperature, high convection. The most important part here is the condensation, latent heat of condensation. Okay. First I'll tell you what exactly is the system, then we'll go in a little bit detail, we'll dig deeper. It's a huge spinning structure made up of large clouds. Okay, so we discussed regarding the clouds. A normal cloud, cumulonimbus cloud. Okay, normal cloud, cumulonimbus clouds, thunderstorms, cloud burst. Then comes tropical cyclone. A thunderstorm can happen anywhere. Cloudburst is a very heavy clouds. Tropical cyclone is like multiple cloudburst continually happening for like 10-15 days. Okay, so very, very heavy rainfall. But it is not like a sudden. So cloudburst, what happens? Like in 2-3 years, it causes everything to drop together and then vanishes, right? So tropical cyclone is there. It is there for like a week or 10 days. Not in a single location, it continuously keeps moving. Wherever it moves, it causes, imagine the situation of cloudburst only, like that. Okay, so that kind of huge system made up of huge clouds. Okay, so I'm describing the characteristics. Huge system. It is a cyclone because it is all driven by low pressure at the center. As long as there is a low pressure, then only this system survives. Okay, so why we will see. It is made up of huge clouds. Not just any kind of clouds. Clouds with a spinning system. The air which is there in the surrounding, this is surrounding, right? This is surrounding. The air here is trying to move at a very fast rate towards the center because the pressure is so low over there. Low pressure attacks the air. The pressure drops at such a fast rate, the entire winds are moving in this manner, like this, converging and rotating like this. Get deflected towards the right side, right? It happens in such a manner that the entire clouds itself are rotating. Can you see? Like you can see the clouds spinning. Spinning cloud system. Not in a manner the way we studied thunderstorm. Thunderstorm, you can see the movement spinning. This is not like that. This is moving. It's a very big structure. You cannot imagine them to be moving as such. Fine. There's a very high wind speed in this. Within this, the wind speed is very, very high because of the pressure difference. Okay, so because of the pressure difference. You can see this is satellite imagery of a tropical cyclone. It has covered the entire Bay of Bengal. Can you imagine the size of this? Okay. So how do we describe a tropical cyclone? There is a low pressure, high wind speed, high velocity wind system with clouds capable of causing very heavy rainfall with thunder, lightning. Okay. Such a heavy rainfall that it can cause floods. It is continuously spinning and moving. This kind of system is what is called as tropical cyclone. Where do you see the formation of these kind of systems? These systems can be formed only within the tropical regions, that too over the oceans only. Only within the tropical regions, only over the oceans. You cannot see them beyond the tropics. Maximum limit is, their formation is only up to 25 degree north. Once it is formed, it may move up to 30-35 maximum, not beyond that. Okay? Only in few occasions you see going up to 35 degrees. Otherwise, normally it is around 30 degrees, it stops. Beyond that, it cannot move. And such kind of huge clouds can be formed only over the oceans. You cannot expect them to be found over the land because land will not have this kind of high moisture. Okay, so you cannot expect them to be formed over land. It forms only over the oceans. It's a self-sustaining system. Okay, so self-sustaining system. What is a self-sustaining system? The pressure is low, it attracts winds, the winds rises, undergoes convection, the convection adds heat, pressure further drops, further draws more air rises, rising air subsides and again goes towards the center. It's a self-sustaining system. As long as this is present over the ocean with warm water, it continues to exist. Okay? Once it moves away from the regions of hot temperature, it becomes weaker. This is what is called as tropical cyclone. Whenever a tropical cyclone comes towards the land area, it causes huge destruction. Very heavy destruction, you would have seen in the news and all. Okay, so it causes heavy winds. Okay, so very, very strong winds, total destruction. People are like, they are not allowed to go out like that. If they are warned, you have to remain indoors. Okay, so and heavy rainfall, like in many places there is a heavy flooding happens. It will take 2-3 days for the water to get cleared like that. Heavy rainfall, heavy winds. So, but once it enters the land, it becomes weaker because it cannot support a very strong convection and cloud system. Only over the oceans it remains strong. These systems are called as tropical cyclones. How exactly they are formed, we'll discuss. Okay, इसके बारे में हम बात करेंगे. Okay, so write the definition. A tropical cyclone is a low pressure. A tropical cyclone is a low pressure, high velocity wind system developed over oceans within the tropics. Developed over oceans within the tropics. So next, conditions required for the formation of tropical cyclones. This is the most important part, conditions. Please try to remember them. Once we understand the conditions, then we'll move on to the formation. You have a basic idea what is a tropical cyclone, right? So that would be sufficient. So this is how the tropical cyclones are formed. What you can see, a very strong cloud system capable of causing heavy rainfall. For this kind of clouds to form, you need a strong convection. And for this kind of strong convection, temperature should be high. Only at a high temperature, you can see this kind of strong convection and cloud formation. Over a period of time, we have observed that the minimum temperature required for this kind of system to develop is 27 degrees Celsius. The temperature of the ocean water, not the land. Land can get heated up very easily. 27 तो कुछ भी नहीं, अभी भी होगा, winter में भी होगा. Okay, so summer में तो और easily हो जाएगा. Ocean water, and that too not a small area, small patches nahi. A very large expanse of ocean water should get heated up by 27 degrees Celsius, 26.5 to 27. Once it crosses that threshold, there is a chance of this kind of strong convection. And this kind of temperature should not only form near to the surface, the water should be deeper enough with this high temperature. So imagine this is the surface area where the temperature is 27 degrees Celsius. It triggers strong convection and results in building up of clouds. ठीक है, शुरुआत तो ऐसे ही होता है. But once this warm water gets evaporated, to fill this warm water, colder water from the bottom will rise up because it has got evaporated so faster. उसको fill करने के लिए नीचे से rise होगा ना, and now this cold water will reduce the temperature and convection stops. The clouds will disperse. Okay, that should not happen. The convection should continuously be happening. Okay, तो ये तो continuously होता ही रहना चाहिए. For that, the warm water should extend for sufficient depth. 27 degrees of temperature of warm water should extend for up to a minimum of 60 to 70 meters. The entire water from the surface up to 60 to 70 meters should get heated up by 27 degrees Celsius. Not just the surface. Imagine the amount of water which is there here, which is capable of causing a strong convection. इतना heat up हो सकता है क्या? Tropical oceans can get heated up. The tropical oceans can get heated up only during the summer. ठीक है? The second condition is depth of warm water. Third, as the convection is happening, the air undergoes upliftment and then it cools down and then it condenses. For that, the air should be humid. Air should be humid. The minimum humidity of the air near to the surface is 50 to 60%. The air should be humid air. If the air is too dry, it will not result in easy cooling down. Easily इतना thick clouds नहीं बनेगा. Minimum of 50 to 60% of humidity should be there near to the surface. Only then when it undergoes convection, it can cool down and results in cloud buildup, and that clouds can sustain for longer duration. ठीक है? Three conditions: temperature 27 degrees, the depth of the warm water going up to 60 to 70 meters, high relative humidity of 50 to 60%. In addition to this, the vertical wind shear. So remember, we use the word wind shear in the topic of jet streams. A wind shear indicates a strong difference in the wind speed at different levels. Wherever there is a strong difference in the wind speed, that creates a strong force. Is it right? There is a strong disturbance and strong force is created. If there is a strong wind shear, strong winds are created, and that strong horizontal winds. Vertical wind shear creates horizontal winds. Right? There is a strong horizontal winds. If there is a strong horizontal winds, the air which is filled with the moisture is swept away. It will not be cooled down here only. It will not result in buildup of huge clouds. So basically, for this system to grow, you need little bit calmer conditions. You don't want too much of strong wind shear and strong difference in the winds, wind speed. You don't need strong disturbance in the air. The air should be little bit calm. I'm not saying stable. Okay, so low pressure, high temperature, but little bit calm condition. Okay, so you don't need too much of strong wind force. Otherwise, the warm, moist air will be swept away. That will not support cloud formation. So you need a minimum vertical wind shear. Wind shear नहीं होना चाहिए. Should not be there. The fifth one is Coriolis force. What is the need of Coriolis force? So this entire region is filled with the air of high temperature and high humidity and low pressure. For this convection to continuously happen, this low pressure should be maintained. यहाँ पर low pressure as it is maintained होना चाहिए. ठीक है? And as the air rises up, it takes the moisture. But to fill this gap, the surrounding air will tend to move towards the center. जहां पर कन्वेक्शन हो रहा है ना, तो जिसके जैसे ये ऊपर जाना शुरू हो गया, तो सराउंडिंग से जो एयर है ना वो पूरा सेंटर की तरफ खींचता है, बिकॉज द एयर इज कंटिन्यूसली राइजिंग, इतना इंटेंसली हीट अप होते जा रहा है ना, इट इज अंडरगोइंग अपलिफ्टमेंट. टू फिल द गैप, सराउंडिंग एयर विल try to reach the center. If there is no Coriolis force, the surrounding air will reach the center. And the surrounding air is of different nature. Temperature is different, humidity is different. And now that will fill this area and that will change the nature of pressure itself. It will equalize the pressure and pressure becomes normal. Convection stops. Cloud buildup also stops. So that means the air tends to move. Definitely air will tend to move, but it should not reach the center. That means you need a Coriolis force so that it can completely cause it to get deflected towards the right side in the northern hemisphere. And as it get deflected, it starts to rotate around this. It almost becomes geostrophic. Itna strong force hota hai na, it gets totally deflected and starts to rotate around this. And as it rotates, it starts to rise like this. It never reaches the exact center. So this air which is trying to move towards the center and starts to rise like this. It is a combined process, convergence and convection. As it converges and convection, the convection causes the air to cool down. There is condensation, cloud formation, precipitation. The strong low pressure is maintained continuously thanks to Coriolis force. Okay? These are very, very important. 5 conditions as it is याद रखना है. ठीक है? Try to remember in the same order. Number 1, high temperature of, लिखते जाओ. Number 1, high temperature of 27 degrees over a large area of ocean water, over a large area of ocean water, supporting evaporation next point. Second, depth of warm water that is 27 degrees Celsius temperature should extend up to the depth of 60 to 70 meters. 60 to 70 meters from the surface. From the surface. Third, humidity. High relative humidity of at least 50 to 60%. High relative humidity of at least 50 to 60%. Near to the surface. Fourth, minimum vertical wind shear. Minimum vertical wind shear. So that humid and warm air is not removed by the strong horizontal winds is not removed by the strong horizontal winds. Fifth, Coriolis force. Coriolis force causing deflection of winds within the cyclone. Deflection of winds within the cyclone. It causes them to move counterclockwise in northern hemisphere. Causes them to move counterclockwise in northern hemisphere and clockwise in southern. ठीक है, 5 condition याद हो गया. So even if I wake you up from sleep and ask you, you should be able to tell. Very, very important part of entire topic is here. See, even if one condition is absent, cyclone will not be formed. Out of these 5, even if one is absent, cyclone will not be formed. For example, near to the equator, you have high temperature, enough depth of warm water, high relative humidity, minimum vertical wind shear, but there is no Coriolis force. No cyclones are formed near to the equator. Okay? Wherever there is a dry air, wherever the temperature is low, cyclones are never formed. Best example, western margins of continents, cold ocean currents. Okay, wherever there is a strong horizontal winds, best example is Arabian Sea. Arabian Sea experiences stronger horizontal winds than Bay of Bengal. So lesser number of cyclones in Arabian Sea than Bay of Bengal. In addition to these 5, there are 2 more supporting conditions. If they are present, the cyclone is going to be stronger. If not, ठीक है, चलता है. 2 more supporting conditions. लिखो, next one. Pre-existing low-level disturbance. Pre-existing low-level disturbance. When I say disturbance, it refers to low pressure. Okay, low pressure is what is called as disturbance. So imagine there is a low pressure developed over land. Okay, somewhere here over the land, a low pressure develops, and this pressure system continuously moves. They are not stationary. And as it enters the ocean, suddenly it gets intensified. Okay? This year it happened, a low pressure was developed here over the land, and as it entered into the ocean, it gets intensified and became a cyclone, 2024. Okay, so I'll tell you what are the cyclones which came. Or maybe there is a low pressure developed in another ocean. There the conditions are not favorable. Maybe there is a strong wind force over there, or maybe less Coriolis force is over there. And suddenly once it enters into the favorable area, it gets intensified. There the intensification is faster. Otherwise also it can form. यहाँ पर भी बन सकते हो. Bay of Bengal में तो बहुत frequently बनता है. Okay, but sometimes whenever there is another depression which is already existing, it suddenly enters, it gets intensified. क्या लिखा है? Which gets intensified to form cyclones. Next, upper divergence. Upper divergence causing convergence near the surface. Causing convergence near the surface. We have studied in jet stream, wherever there is upper divergence, it causes lower convergence. Okay, so in the atmosphere, if the conditions are such that there is a divergence, okay, definitely it causes a strong convection. Strong convection is anyway required for cyclone formation. Let's see with these conditions how a cyclone is formed.
There are three basic stages in the life of a tropical cyclone: its origin or source, the mature stage, and the dissipation stage where it dies out. These occur in a continuous process, not as separate and distinct stages. There are three basic stages in the life of a tropical cyclone.
This is just the beginning part. You can see clouds are just forming and they're converging, and the air is converging and rising, and the system is just building up. And from here, it gets intensified. So this is the mature
Its
part.
origin or source, the mature
This is the mature
stage,
part. A proper well-developed
and the
cyclone.
dissipation.
When it gets dispersed. The clouds are no more a single system causing a very heavy rainfall. Okay, so as well as winds, just disturbed.
Stage where it dies out. These occur in a continuous process, not as separate and distinct stages. Each stage may
This is
occur
a
more than
time-lapse.
once during the life.
Okay, time-lapse video of the cyclone moving. Okay, you can see it is originating from here. Almost it is strengthened. You can see already it is there. And as it moves, it intensifies. A cyclone never remains stationary. It continuously keeps moving.
In distinct stages. Each stage may occur more than once during the life cycle as the strength of the cyclone rises and falls. It may reach land, weaken, then go back out to sea where it strengthens once more. The formation of a cyclone depends upon the following conditions coinciding: a large, still and warm ocean area with a surface temperature that exceeds 26.5 degrees Celsius over an extended period. This allows a body of warm air to develop above the ocean's surface. Low altitude winds are also needed to form a tropical cyclone. As air warms over the ocean, it expands, becomes lighter, and rises. Other local winds blow in to replace the air that has risen, then this air is also warmed and rises. The rising air contains huge amounts of moisture evaporated from the ocean's surface. As it rises, it cools, condensing to form huge clouds about 10 kilometers up in the troposphere. More warm air rushes in and rises, drawn by the draft above. The rising drafts of air carry moisture high into the atmosphere, so that these clouds eventually become very thick and heavy.
The presence of a large surface area of high temperature with enough depth of warm water with less minimum vertical wind shear, enough Coriolis force. Okay. It starts with a strong convection. As the convection starts, there is a huge rising air which starts to build up strongly. Convection के वजह से. What happens during the convection? The air which is present here carries that water vapor which is getting evaporated from the surface, and it rises up. As it rises up, the air cools down. Okay, because during the convection, it reaches the upper part of the atmosphere, it cools down. And as it cools down, the water vapor present in the air will get converted into water. As it cools down, water is formed and then clouds are formed. And clouds build up.
Condensing to form huge clouds about 10 kilometers up in the troposphere. More warm air rushes.
The central part is where there is a strongest low pressure. That is where there is a highest temperature. So therefore you can see thick clouds at the center. As you move away from this part, the thickness of the clouds decreases.
Is in and rises, drawn by the draft above.
From here, how the clouds become intensified. See, the same system, if it is formed over the land, it can form over the land also. But when it formed over the land, the rainfall will cool down the land. The continuous rainfall which is happening, it's never like a cloud burst. It's not like no rainfall and suddenly drops. Rainfall is continuously happening, but the rainfall will not be able to cool down the surface. There's so much of warm water here. Okay, so rather it will fuel further strong convection. How? The air is getting heated up due to the release of latent heat of condensation. Okay, so remember latent heat of condensation? The heat which is observed from the surface is released into the atmosphere. Air starts to become hotter. With higher temperature, the capacity increases. More water vapor can accumulate and more clouds build up. The clouds start to become bigger and bigger. What is the fuel of this system? Latent heat of condensation, which is keeping the system continuously running. And that heat is coming from the water surface. Only the water surface, big oceans, can store this much of amount of heat. Lands will not be able to store. It will get heated up. You cause rainfall, it will cool down. So therefore, system will not become bigger and bigger every day. Here it can grow to become bigger and bigger.
These clouds eventually become very thick and heavy. Condensation then releases the latent heat energy stored in the water vapor, providing the cyclone with more power. This creates a self-sustaining heat cycle.
So, what happens to the rising air? The rising air, there is a strong convection happening at the center, right? It reaches the edge of the troposphere, it gets diverged. And as this air comes out of the system, there it starts to subside. Okay, where there is no convection, जहाँ पर convection नहीं है, वहाँ से नीचे उतरना शुरू होगा, it starts to subside. And as the air at the center is rising up, this will create further suction. Because the air is rising up from, this is a huge, imagine a circular area. Okay, so it creates a suction. The air from the entire surrounding area begins to move towards the center. The air which is subsiding, that itself will start to move towards the center. The same air now rises up and again subsides down, again rises up, again subsides down. During this process, it is continuously transferring the heat from the water to the atmosphere, which is causing the clouds to continuously build up. There is rainfall. During this entire process, during the entire 7 to 9 to 10 days, wherever there is cyclone, everywhere it is causing rainfall. Imagine a system which is continuously causing rainfall only. So air subsides from the outer part, from the in-between part also. Earlier this was a huge thick clouds. Gradually it starts to become bands. Okay, why there is a banded structure? See, if this is the cloud with everywhere there is clouds. Okay, हर जगह में clouds है. So that means there is a strong thick clouds. But बीच-बीच में थोड़ा सा bands आने लगेगा. यहाँ पर clouds है, thick clouds. फिर यहाँ से ऐसे आएगा, फिर यहाँ से ऐसे आएगा, यहाँ से ऐसे bands बनेगा. क्यों? Because the air which is rising here is subsiding here. जहाँ पर subsidence होगा वहाँ पर clouds clear हो जाएगा ना. The subsiding air will not result in the cloud formation. So यहाँ पर clear, यहाँ पर clear. In between you can see the clear sky. That creates gaps. Therefore it appears like bands. Most importantly, Coriolis force. The low pressure attracts the winds to move towards the center. If these winds move towards the center from away, it will neutralize the pressure, equalize the pressure. The Coriolis force causes them to undergo deflection and move around the center. It will never go straight, it completely gets deflected in the path. By the time it is rotating and moving towards the center, due to convection, it rises up. So the center always maintains that low pressure. Okay, high temperature, low pressure, winds are trying to move towards the center. At the same time, it is rising and convecting. And rising system causes condensation, cloud formation, precipitation. The same rising air comes down and again moves up. By now, the entire system is so self-sustaining that it causes continuous rainfall. Only that you have to maintain a high temperature of water. As long as it is going through the region of high water temperature, it survives.
Drawn further upwards by the new release of energy, the clouds can grow to 12 to 15 kilometers high. The force created by the Earth's rotation on a tilted axis, the Coriolis effect, causes rising currents of air to spiral around the center of the tropical cyclone. It is at this stage that the cyclone matures and the eye of the storm is created. As the air rises and cools, some of this dense air descends to form the clear, still eye as the cyclone rages around it.
See, till here the cyclone was almost matured. Okay, thick, dense clouds are formed everywhere. The air is rising up, subsiding down, moving towards the center, rotating and rising up. With the release of more heat, more thick clouds are formed, and at the center, huge cumulonimbus clouds. It's a wall of cumulonimbus clouds, okay, covering a very big area. In that, whatever the air which is rising, okay, so it is creating such a strong convection. Whatever the air which is rising, some of the air, because of its high density, ये यहाँ से इतना बाहर जाने का भी इतना मौका नहीं मिल रहा है इसको. There's huge amount of air rising. Some of this air will start to subside here itself. अपने weight के अंदर ही ये यहीं पे नीचे उतरना शुरू हो जाता है. Once it subsides, it comes down, again rises, again subsides. Most part of it is moving away. ये बाहर जाके ऐसे घूम के ऐसे के फिर ऐसे बाहर निकलता है. It spreads out like this. Now a part of this air starts to subside here. Because the entire central part has become so thick and dense, even a small part of the subsiding air is sufficient to clear the sky. एक बार वहां से नीचे उतर गया, subsiding air will clear the sky. There is no cloud here. Okay, पूरा clouds clear हो गया, बारिश कम हो गया, बारिश पूरा के पूरा बंद हो जाता है. That part is what is called as eye of the cyclone, eye of the storm.
It is at this stage that the cyclone matures and the eye of the storm is created. As the air rises and cools, some of this dense air descends to form the clear, still eye as the cyclone rages around it.
Not every cyclone develops eye. It is not necessary. Only a matured and very strong cyclone develops eye. Formation of eye indicates that it is going to cause a very heavy destruction. Okay, so otherwise also it can cause, it is not necessary, but it is only at the later stage. Some of the cyclone reaches this stage and from here only it starts to become weaker. It may not see the formation of eye every time. So now, once this kind of system has been formed, it moves under the influence of, it was already moving, see, it was never a stationary. Because एक ही जगह में इतना तो convection होने का उतना strong temperature नहीं मिलेगा. As it moves over the water, it continuously becomes intensified. What is the direction of movement of these cyclones? किस direction में जाएगा? They are under the influence of trade winds. They usually move from east to west. This is the direction of their movement. The general direction is east to west because they are under the trade wind belt. This is a huge system. Now, try to see this cyclone as a single body which is moving on the surface of Earth. Any big-sized body moving on the surface of Earth experiences Coriolis force. Under the influence of Coriolis force, it gets deflected towards the northwest direction. That is why a cyclone always moves towards northwest direction. If it is formed here in Arabian Sea, it goes towards the northwest direction, either northern Andhra Pradesh or Odisha or West Bengal. That is why I asked eastern coast. If it is formed somewhere here, it moves towards this direction, moving towards Oman, Yemen, Saudi, UAE or Pakistan. Okay, so very rarely it turns like this. There is also that phenomena. We call it as recurvature. I'll tell you that. Very rarely it happens. But otherwise, the general direction is this direction. Because a single body moving in this direction gets deflected towards the northwest, towards the right. And as long as it is moving over the water surface, it survives warm water surface. If it enters a land which is very big area, and as it encounters the land, the source of convection is cut off. What is the source of convection? The warm water. Warm water जैसे खत्म हो गया, convection थोड़ा बहुत down हो गया, then the cloud starts to become weaker. जितना हुआ था वो बारिश होगा, फिर disperse हो जाएगा. ठीक है? It becomes dispersed. The entire system dissipates. If it passes over a island area, for a temporary period it becomes weakened. Again, as it enters the ocean, it becomes again stronger. That happens over Caribbean Sea. Okay, so as it passes over island area, it becomes weakens temporarily, and then once it enters the ocean, it becomes stronger again. The entering of a cyclone over the land is what is called as landfall. Okay, for the landfall to happen, the central part has to enter. जब तक जो eye of the cyclone है ना, जब तक वो ocean में है, तो तब तक convection चलता ही रहेगा. Imagine the entire cyclone, ये जो part यहाँ पर आ गया, okay, ये पूरा system ऐसे है. आधा cyclone ये पूरा यहाँ पर बारिश हो रहा है. The entire area is seeing a very heavy rainfall, and the strongest rainfall is that region wherever there is a landfall. Okay, heavy winds, thunderstorm, lightning with heavy flooding also. ठीक है? This is what is formation of cyclone. Okay, so लिखो जल्दी. Point wise, strong convection, along warm ocean water surface result in buildup of huge cumulonimbus clouds. Huge cumulonimbus clouds. Next, release of latent heat provides more energy to the system. More energy to the system, supporting further strong convection. Next point. Rising winds diverge in the upper troposphere. And starts to subside. Full stop. This descending air move towards center and rise through convection. Causing the entire system to stabilize. Next point. The lateral winds near to surface start to rotate around the low pressure center. Start to rotate around the low pressure center due to Coriolis force. Next point. Once the entire system is stabilized, and the cyclone matures, some of the dense air rising near the center, starts to descend resulting in the formation of I. Next point. A tropical cyclone continuously moves under the influence of trade winds and get deflected towards northwest direction. Next point. As it enters cold waters, or the land, it weakens and the cyclone dissipates. Okay. So that is a basic idea. We have studied the most important part actually, conditions and formation. There are few more things I have to add. Okay, so that I'll continue tomorrow. And after that, we'll start with climatic regions. Take care. Thank you.